That's something good. Oh yeah. Oh yeah, it's a monster. Oh yeah, look at that mother. Woo! There we go. Woo! I want to get a length on this because this is definitely, I think, my biggest snakehead that I've landed and got a photo with. Mind getting a photo? Thanks. Look at those, nice pattern. A little slippery on me. Woo!
Okay, so today we're with Dr. Noah Bressman from Salisbury University, and we are going to scientifically process a snakehead.
Yeah, so we're going to be doing a few different projects with these snakehead. The first one is going to be looking at the effects of their slime. Snakeheads can move over land, not necessarily fast enough to chase down a kid or a baby or anything like that. I'm trying to figure out how much does that slime reduce the friction, and to figure out their adaptations to help them move over land, and also to help inform how ways to reduce the friction in amphibious robots inspired by snakeheads that we're working on that are having trouble overcoming friction, and so we're trying to match that to help with that.
That's pretty cool.
Then the next part is we're going to cut open the snakehead, take out their stomachs and see what they're eating to figure out what are they eating. We're trying to study their feeding ecology on the eastern shore to figure out, are they eating striped bass, are they eating blue crabs, any other species of concerns, and if so, how much are they? Are they specializing in only eating baby striped bass, or are they eating a little bit of everything? And then we're also going to take take a tissue sample so that we can do what's known as stable isotope analysis. Which gives us a longer term view than just a single meal that may be in the stomach right now.
Hey! Sorry, I hate to interrupt Dr. Bressman's flow here, but I find this topic to be absolutely fascinating, and I want to elaborate on it. What the heck is stable isotope analysis? Periodic elements, atoms, usually have a specific number of protons in their nuclei, but the number of neutrons in those nuclei can vary. Whenever you have an imbalance between the protons and the neutrons in the nucleus of an atom, it's called an isotope. The bigger the imbalance between the protons and the neutrons, the more unstable that isotope becomes. Well-balanced isotopes, like carbon-13 and nitrogen-15, have very stable nuclei, especially in contrast to maybe their more radioactive counterparts like carbon-14, which we may hear about when we talk about carbon-14 dating. We're not looking at radioactive elements here. We're looking at stable isotopes, isotopes that stay intact for long periods of time. Atoms, the fundamental building blocks of all the things that surround us. These isotopes are in our water, they're in our plants, they're in our food. When we consume them, they literally become part of our living tissue. By analyzing samples of tissue and bone, we're able to figure out certain things about the environment the sample animal came from, including the types of food that sample animal consumed, and even where that food came from. The technique, stable isotope analysis, is used in a number of different research fields, including archaeology, and biological research. Sorry for the disruption. I just had to geek out on that for a second.
I like science.
Okay. How about ear bones?
Ear bones, so sometimes we take ear bones of fish to age them, so we can do age and growth, but we're not really doing an age and growth study on the snakeheads. We're doing that on the catfish, just because the catfish are a little more of concern right now, and it's a little more known. There's been some other studies on the growth rate of snakeheads. Friction experiments, I'm doing them on two different surfaces. One is this table, foldable table, because we can bring it anywhere and do some stuff in the field, and it's a good representative, just general smooth surface for somebody to be moving on. But over here on the ground, you can see this is artificial piece of turf to simulate a more grassy, complex ground, and to understand the effects of friction may have on both terrains. So we got weight was 7.11 pounds. The length, 70.2 centimeters. Terrible fish.
Not.
I'm going to throw this one out.
All right. So what do we got next?
Next step is I got to get the force meter ready, which will just take 1 second. And there's an app that I use for the force meter that can log all the data on there. I'm measuring what's known as static friction, which is the friction needed to overcome a stop to start.
Gotcha.
So I'm going to basically pull on it very slowly, and it's going to record the force at which the fish starts moving. And I'll do that a few different times so that I can get multiple different data points that I can then average that together and have a more a better representation.
Bigger sample size, better data.
Exactly.
On the graph, you'll just have time on the x-axis and then force on the y-axis. And when I start pulling, I'll have this face in here, and you can see from there what it'll look like. Yeah, I first pull it forward on the table, then I pull it backwards.
Okay.
You kind of see, I'm also testing to figure out how the scales may help them move one way, not just go back and forth on line. Then I'm going to do, well, it's already clipped in backward on here, forward on here. Then I'm going to wipe off all the slime and then repeat that to see how the slime affects their force that it takes to move around.
So you're looking for a delta between the measurements.
Exactly.
Okay.
Looking for a change in the measurements.
Okay. We're all about scientific literacy here at the
I use this clip on the lip just because it grips good enough. But I haven't done this yet on one this big. So let's hope it works.
What's the objective in terms of number of fish you would like to include in your sample?
For this, I would like at least 30. That'll give me enough to determine normalcy in the population, which is just basically a fancy word to make sure that the data is representative of the population and not skewed by perhaps the fish that I chose based on size randomly.
Okay, cool. So 30. And how many snakeheads do you currently have?
3.
3. Okay.
So we're working on it. We're going to have 4 after this.
Fantastic.
So let's see. Okay, so now it's in state of rest.
Okay.
I'm going to press start so it starts recording. You can film that in the graph.
Okay.
You can see what it looks like. So now I'm going to gently.
Now, are you starting and stopping?
Yes, I'm starting and stopping.
Okay.
So you can see. So now I stopped that. That's the first data series, and then.
So that's the forward data series.
Yeah, that's the forward. And now to do backward, I have to do a little bit different of a thing. Clip it around to here. So I clip this thing that this hemostat, this forceps that lock.
Mm-hmm.
So I clip that on the fin, but I gotta clip this through. And let's hopefully I try to get as upright as I can. So now I'm gonna start. This is backwards.
One, three.
Okay. That's 5. Sometimes I'm pulling a little harder than others, which is why I'm doing 5 of them to get some replicates so then I can average together and that gets a little more representative sample.
Awesome. Come on, you can do it. There you go. Mm-hmm.
Surface. And the scales orient backwards. So imagine going forward, they go nice and smooth. Going backwards, they can kind of lock up and dig in. And I'm trying to study. That's the difference in the directionality of force is known as anisotropy. And so that affects how things move forward and backwards. And that's why snakes just don't stay where they are. Where they pass a wave down, the friction forces is different depending on the orientation of their scales on the belly. So that way they can push backwards without also pushing forward. If you put a snake on something like carpet or a smooth surface, it'll just go in, it won't be able to move because it's not able to get enough traction on the surface. It just stays in the same spot.
So I'm curious as to what the slime is made of.
So fish mucus is made of glycoproteins, which is basically just a mixture of carbohydrates and proteins. That's the mucin component. Mucin being is that protein, glycoprotein component that isn't water, and then mucins generally absorb water.
Okay.
So I actually did a lot of research on hagfish slime, which is its own category of slime. It does its own weird thing where it's also got it's got different types of mucin or mucin-like vesicles, and it's also got these coiled proteins that are like these little threads packets. And when they hit water, they unravel and these are microscopic cells that unravel to about half a foot long. And these things are comparable in strength to spider silk or
I've seen
cotton.
a documentary on hagfish slime.
Oh, nice.
Yeah. Yeah.
I had one come out this week. Is that the one you're referring to? Or?
No, this was a year or so ago.
I had one come out on Tuesday. Well, the link pops up in the flower.
Definitely. You know, I have to wonder how many people are watching this and thinking to themselves, wow, I have that same table at my house, and I use that to clean fish all the time. You know, that scale is just like the scale that I picked up at, Bass Pro Shop.
I'm all about that low-cost research, because most of my research, I just need the fish, and so I gotta go out fishing and catch the fish, and then doing simple things like this. These aren't very I'm answering interesting questions using simple methods.
Do you crowdsource any of your fish collection?
Sometimes, yeah. So if people have accurate, like if they get it from the same body of water we're doing this research, the Nanticoke River system, including like Barron Creek and Marshy Hope, if they can get us accurate weights and lengths and images of their diet contents, we can use that. But what's especially helpful is somebody take a little tissue sample, just take a little piece of tissue from just right on the left side of the dorsal fin, just a little bit of muscle tissue, and we can use that if it's frozen for something known as stable isotope analysis, and that's where we compare the different ratio of isotopes to figure out what they're eating.
Okay.
Or they can just drop off the fish in my lab, and I'll happily take that and do all the work.
So again, check out in the description if you're fishing in the Nanticoke area and you happen to get into some snakeheads that you personally do not have any use for, they could actually contribute to the research being done at Salisbury University.
Mm-hmm. And sometimes a lot of the scraps we use of these fish after we're done, we go to feed the animals at the zoo. So you can also help with that.
Oh, fantastic.
Okay, that's that. So what I've been noticing is on the smooth surfaces, the slime makes a big difference in both the forward and backward direction to help it move. But it's not that much more moving backwards than forward. But on the rougher surfaces, there's a lot more stuff for it to grip onto. So the slime doesn't make that much of a difference compared to forward or backwards on the turf, just because those scales digging in outweigh the effects of slime.
Okay. And there's less surface area making contact on the turf than there would be on a smooth surface like the table.
Exactly, especially when it comes to adhesion, where the more surface think of more surface area where you have glue, the more that it would stick.
Got it. Got your knife?
You can get me one of the smaller bags in there.
I noticed it's got cool stickers.
Yeah. Snakehead 7/15/22. We always take it from the the left side of the dorsal fin, just to be consistent, because different tissues may have different isotopes, so we want to keep it the same across all the different individual fish.
Got it. This is the part where the snakehead jumps.
You never know. Sometimes if you hit the spine, the nerves along the spine, sometimes it will jump up, and it's still dead, but it's still the cells in it still have some energy because it's freshly dead. So hitting the spinal cord, you can activate a lot of the nerves and just cause it to jolt. There you go. So there's a tissue sample. That's all I need to process it. It's a little tissue sample. It should be enough. Seal it up.
Outstanding.
Okay, now for the stomach. Nice, fun, gross part. Nice little chunk there. So I'm not sure if there's anything in the stomach. Gloves are optional. So a big thing is if you're working with mammals or birds or something else like that, gloves are mandatory. But on fish, you're less likely to get a disease from a fish because they're not as closely related to us as another mammal.
Are you able to determine at this point whether this was a male or a female snakehead?
When I cut this out, I can check for gonads. If I can see any, I can let you know.
Because is it true that that's pretty much the only way to tell for sure is to dissect them?
Yeah, I cut them open, look at the gonads. There may be very subtle characteristics, but just being subtle doesn't necessarily mean, like, because you think it's a characteristic, like, I don't know, this one looks a little dark or this one looks a little light. It could just be a time of day, mood, water quality, all that stuff. Snakeheads are actually really interesting. They because they have this air-breathing organ up here, there's this pocket of air. And so their swim bladder, actually, the rib cage goes all the way down pretty much to the tail. And after about the anus, nothing in that rib cage except for that swim bladder. And so it goes all the way down, and that way it kind of balances it out so they can stay horizontal without their head tilting up.
Here's some of these nematodes, I believe, and these are often found in the body cavity, and these are often just found in the body cavity. They're not necessarily in the meat, but we'll find out when I fillet it if it's in the meat.
I was, when I try to examine stomach contents on my own to try to figure out what the fish are eating at any particular time, it's always irritating because you go and you cut them open and it's empty, and then you go, oh, well, that makes sense. They were trying to eat my lure because they were hungry.
But oftentimes you don't see anything in the stomach if they're going to bite. This could be something, actually. Something small. I don't think there's anything in there.
Yeah, a little let down, Noah.
Sorry, the day's ruined. You can see little bits of stuff that you eat from previous meals, perhaps.
Scales or
little bits of bone, maybe. So that's it.
Okay.
Not much, but we could still figure out what it's eating based on that tissue sample by figuring out maybe not what it ate right now or what it ate most recently, but we can figure out over the course of its life, which fish it's mostly eating, what is the diet mostly made out of it. Fish, frogs, clams, you name it, anything we get tissue sample from the river, we can compare it to that.
Why don't you tell me about this tournament you got coming up on the 30th?
All right. So on July 30th, my lab got a grant from the Maryland Department of Natural Resources to host a fishing tournament on the Nanticoke River, where our study system is, including all the tributaries. So Barron Creek, Marshy Hope, and all the other creeks connected to it, as long as they go into the Nanticoke River before going into the Chesapeake Bay. Any of that's fair game. I figured we get hundreds of anglers to go out all at once. If everybody catches one fish, we'll have 200 fish or so, and that'll be more than enough we can use for the study. For both snakeheads and blue catfish, and any flathead, if anybody happens to catch a flathead catfish, they haven't been documented in this river yet, but we'd be interested to see. That'd be awesome when we document it during this tournament. Bad for the ecosystem, but if they were there, if we documented this tournament, that'd be really cool. But we have over $2,500 of prizes in gift cards as part of the grant to give out. There's no entry fee, free registration. As many people as we want can be there. You could fish on a boat. There's kayak divisions. There's shore-based. If you want to fish from the shore, you could fish at the Cherry Beach Park in Sharptown, Maryland, and that is where the weigh-in will also be. We have fishing gear. We got about 15 fishing rods or so, and maybe we'll get some more rigged up. If you don't have any fishing gear, you've never gone fishing before, we could teach you how to fish so you too can catch these fish. And so this event has multiple benefits. One is, first off, we're getting these invasive species out of the ecosystem and perhaps mitigating their effects and lessening their effects on the ecosystem. The second effect is we get all this data points that we can then use for our research, all these samples for our research. And third, people get to have experience in catching these big fish that fight hard and taste really good, particularly during the time when the striped bass moratorium is in Maryland, where striped bass season is closed. And we want to encourage people to go for these invasive species, perhaps as an alternative, because the invasive species pose a threat to the striped bass. They're competing with them, they're eating them. And striped bass are also, their population's struggling. They're pretty low and they're on decline. So maybe if you have fun with snakehead and catfish fishing, maybe try targeting those a little bit more and let the striped bass reproduce and recover. Hope to see you all there. We also got some prizes from Addiction Baits. We're going to be giving out some lures and other prizes they gave away. We got Drake Realty Group is giving out a $100 prize for the biggest snakehead and blue catfish combo. And we also got Old School Tackle Baits. Old School Baits are giving out some baits at the event as well.
Awesome.
So it should be a great time and should be a great weigh-in. Tournament starts at 5:30, where you can launch at 5:30 from any tributary of any boat launch along the river. And then at 6 is lines in. And then at 2 p.m. is the weigh-in. And that will be where the fun is, and after that, prizes, and we'll be processing the fish there with a lot of volunteers, and so you could come up and see what we're doing, see the researchers, see firsthand. A lot of it looks like what you just saw, but hopefully we'll have a lot more fish with all sorts of crazy things. We've seen things like whole ducks in catfish stomachs, 20-inch striped bass, blue crabs, you name it, sticks, rocks, mud, anything is fair game. They're pretty much the tiger sharks of the Chesapeake Bay, so come out, see what they're eating, and have a good time.
All right. Well, there you have it. Science is afoot right here on our very own Chesapeake Bay. I want to say a special thank you to Dr. Nora Bressman, a special thank you to Salisbury University for spending some time on the water with us that day and showing us exactly how this research is conducted. Really want to encourage everybody, if you can, to participate in the tournament on July 30th in support of Dr. Bressman's research. As you can tell, he's a really good guy, very knowledgeable, and is part of our own community. At the end of the day, that's what the Legion is all about, building community one cast at a time. Thanks for tuning in. I hope you enjoyed it. It's never too late to care again.